right, section 5.6, essential question. How do you find the possible rational zeros of a function? Okay. First thing you have to do is just list the possible rational zeros. You can list the possible rational zeros by finding the factors of the last term and dividing it by the factors of the leading coefficient. Okay. And this is pretty easy how to do, and we'll show you how to do that. Okay. So like this first one. Okay. What we're going to do is find the factors of 12, which I like going from smallest to biggest, which would be factors of 12 would be 1, 2, 3, 4, 6, and 12. Okay? And we're going to divide it by the factors of the leading coefficient, which in this case is 1. Okay? So if you divide anything by 1, it's itself, so really the list is just going to be all those numbers on top. And that would be your answer. Those would be the possible rational zeros of that function. Okay? Go to the next one. Okay? This one, the factors, we want to like the factors of negative 10. So now I go from least to greatest because it makes sense. So we go 1, 2, 5, and 10. And we divide it by the factors of the leading coefficient, which is 4, which would be, I'm going to list these from biggest to smallest because I want to divide my smallest by the biggest to keep my order from least to greatest. I'm not going to count you off if you don't do this, but it just makes it simpler for me that I don't have repeater numbers. So all the factors of 4 are 1, 2, and 4. Okay. So then what I'm going to do is take my first number, if there's more than just one number, and I'm going to divide 1 by 4, 1 by 2, and 1 by 1. That should give me my number from least to greatest. And I'm going to do 2 and divide by 4 and divide by 2 and divide by 1. Then I'm going to do 5 and do it by 4, 2, and 1. And then 10 by 4, 2, and 1. So if I divide 1 by 4, I get 1/4. 1 by 2 is 1/2. 1 by 1 is 1. Which may plus or minuses. Then we go to the next one. 2 divided by 4 is 1/2. I already have it. 2 divided by 2 is 1. I already have it. But 2 divided by 1 is 2. I don't have that. Okay. Then we go to the next one. 5 divided by 4 is 5 fours. Which I know it doesn't give us exactly the order we want because 5 fours is less than 1/2. But you get the picture. 5 divided by 2 is 5/2. Don't have that. Then we got 5 divided by 1, which is 5. Then we go to 10. 10 divided by 4 is 5/2. We already have that. 10 divided by 2 is 5. We already have that. But we don't have 10 divided by 1 is 10. And that would be all the possible rational zeros of our problem. Okay. So, what it says, find all the real zeros. First thing you want to do is what we just did, list all the possible rational zeros. So we want factors of 20 divided by 1. Well, anything divided by 1 itself, so really all we got to do is list the factors of 20. Which in this case would be 1, 2, 4, 5, 10, and 20. Okay? And we're going to start from the smallest numbers to the biggest numbers, okay? We're not going to use the graphing calculator quite just yet. We're just going to test these numbers to see which one works. So we're going to test them using synthetic division and see if we get a remainder of 0. If we get a remainder of 0, we know it's a true 0, and we can break the problem down and rewrite it. Okay? So let's start off with 1, see if 1 works. List it out. Synthetic division, we got 1, -8, 11, and 20. So we bring down to 1, that makes 1, -7, makes -7, 4, that makes 4, that makes 24, it does not work. Okay, so let's try another one. Let's try -1. We got 1, -8, 11, and 20. Bring down to 1, -1 times 1 is -1, that makes -9, that makes 9, that makes 20, that makes -20, that makes 0. Okay, so -1 does work because we have a remainder of 0. So what we need to do now, section that off, we don't need that anymore. is rewrite this in factor form. So we rewrite this as x plus 1. We rewrite this as, remember we did x cubed, and we divided by an x. So it's going to be 1 less x. So it's going to be x squared minus 9x plus 20 equals 0, because we're trying to find zeros. Okay? Now, we have it as a nice quadratic that we can factor. We can find factors of 20 that add to -9, which would be -5 and -4. So we can rewrite this in factor form as x minus 5, x minus 4. So we can bring down our x plus 1, and then write it as x minus 5 and x minus 4 equals 0. Okay? So our three answers are going to be -1, +5, and 4. Okay? And that's how you would solve that. Now, that would be a lot quicker if you use the graphing calculator, but there's a problem on a test where I wouldn't let you use the graphing calculator. That's how you would go about doing it. Let's go to the next one. Okay? This one, we're going to do the same thing. First, we're going to list all the zeros. So we're going to do factors of 8, which would be 1, 2, 4, and 8. And we're going to divide it by the factors of 2, which are 2 and 1. So we're going to do 1 divided by 2, 1/2, and 1 divided by 1 is 1, 2 divided by 2 is 1, 2 divided by 1 is 2, 4 divided by 2 is 2, 4 divided by 1 is 4, and 8 divided by 2 is 4, and 8 divided by 1 is 8. Okay, so you don't have to list them twice, just once, and that would be our list. Now, when you have fractions or decimals, what I would recommend doing is actually now using our graphing calculator. Okay, so let's put this in our graphing calculator. So we have 2x to the power of 3 minus 3x squared minus 3x squared. What was the rest of it? Minus 18x minus 8. Okay, so we graph this. We see that it crosses at -2, and it crosses in between -1 and 0, and crosses at 4. So where does it look like on the graph where it crosses between -1 and 0? What possible rational zeros do we have? The possible rational zeros we have between -1 and 0 is -1/2. Okay, well, we wouldn't know to look for that unless we listed our possible rational zeros. That's why it's very important to do that. Okay, so you can use any of those that you want to solve for your rational zeros. I think I'm going to use -2 just because I want to, but you can pick -1/2, you can pick 4, and they'd all work out. Okay, so and you're asking, well, we'll talk about that. So -2, if we use -2 as a factor, we're going to do 2, -3, -18, -8. So if we bring down the 2, that makes -4, -7, that makes 14, that makes -4, that makes 8, and that makes 0, so it does check out. Okay, so, and we knew it was going to check out because we saw that across the -2 per the graph. So then we can rewrite this in factor form. That would be x plus 2. Again, remember we started at x cubed and we divided by an x, so it's going to be 2x squared minus 7x minus 4 equals 0. Okay, then we can find factors of, now we got to do the AC method. Okay, in this case, so if we do the AC method to find out the other two, which I know we already know, but later you're going to have to be able to do this to find imaginary zeros and irrational zeros. So if we find factors of -8 that add up to -7, which in this case will be -8 and 1, then we can rewrite it in factor form as 2x squared minus 8x plus x minus 4. Then we can factor by grouping. We take out a 2x, and we're left with x minus 4. Nothing to take out here but a 1, so we're left with x minus 4. Okay? So when we rewrite it, we have 2x plus 1 and x minus 4. And we can also drop down our x plus 2 equals 0, because we're just still trying to find our zeros. So the answer is what makes those go to 0. What makes x plus 2 go to 0? Negative 2, which we already knew. What makes 2x plus 1 go to 0, which we already saw in the graph. It's negative 1/2. And what makes x minus 4 go to 0 is 4. Again, it seems like a lot of work. I know what you're saying. I know what you're thinking. Well, the graphing calculator already told us those are our answers. Why are we doing this? Because we have to break down the problem later in 5.7 when the roots are imaginary or complex. We have to break down the problem using the ones we do know, the rational zeros, to find those. Okay, so that's why we're just practicing breaking it down right now. We're just getting practice. Okay, let's go to the next one. Okay, so I have a pyramid. Some ice sculptures are made by filling them with water then freezing it. You are making such an ice sculpture for a school dance to be shaped like a pyramid with a height that is 1 foot greater than the length of each side of a square base. The volume of the ice sculpture is 4 cubic feet. What are the dimensions of the mold? Okay, so I looked up on Google the formula for a pyramid: length times width times height divided by 3. So the length is x, and we want to find the dimensions of it. So length is x, the width is x, the height is x plus 1 divided by 3 equals the volume, which is 4. Okay, so we want to find the dimensions. So the first thing I would do is multiply the top. X times x is x squared times x plus 1 over 3 equals 4. Okay. Then the next thing I do is distribute the x squared. So I get x cubed plus x squared over 3 equals 4. Now, no one wants to mess with messy fractions, so what I would do is multiply by 3 on both sides. I want to do a fraction. So multiply both sides by 3. Okay. And I would get x cubed plus x squared equals 12. Well, I'm trying to find 0, so I need to set it equal to 0 and solve. So I'm going to subtract 12 from both sides. And I will get, let's section this off, x cubed plus x squared minus 12 equals 0. Okay. So then, now what I want to do is list the possible rational zeros. Okay. And actually, well, let's list the possible rational zeros. So it would be 12. So we'd have, factors of 12 would be 1, 2, 3, 4, 6, and 12. Okay. So those are all the factors. Those are all numbers going to 12. But if we can reason, which I already made one of these videos and mess this up, think about it logically. You can only have positive answers. You can't have negative x. Negative x won't work in this case. Can't have a negative length, width, or height. So let's just use the positive ones, and I can narrow down a list of ones we have to guess and check if we did not want to use a graphing calculator. Okay. So let's pick one, because we know it's got to be positive. Let's try 1. So if we try 1 into this formula, we'd have 1, 1. Notice how it goes x cubed, x squared, but there's no x term. So we have to put a 0 in for it. And then negative 12. So if we do that, we bring it down to 1. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. That makes 2. That makes 2. That makes negative 10. That does not work. Okay. So let's go to the next positive answer, which would be 2. Let's try 2. So we got 1, 1, 0, negative 12. So we bring down to 1. 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. That makes 6. And 2 times 6 is 12, and that makes 0. Okay. So that one does work. 2 is going to be your answer. Okay. So let's rewrite it back to form. Okay. we have x minus 2. Again, remember it started off as x cubed and we took away an x. So this is going to be x squared plus 3x plus 6 equals 0. Okay? So just because we got a little, because I want to show you this, okay? Well, let's see. Can we do factors of 6 to add up to 3 or anything that multiplies to 6 and adds up to 3? No. So we can't do it that way. And b is not even, so we don't need to complete the square. So what you have to do if you want to solve this part is do the quadratic formula, okay? So we don't have to do this part, but this is why I'm showing you why we're doing this when you get to the next unit of 5.7. So if we use quadratic formula, the x equals opposite b, -3, plus or minus square root, b squared, which is 3 squared is 9, minus 4 times 1 times 6, all over 2 times 1. So if we break this down, we got x equals -3 plus or minus square root 9 minus 36 all over 2. We keep going. -3 plus or minus 9 minus 36 to -27 all over 2. Notice how we have a square root of negative, okay? So if we keep breaking that down, 27 breaks down into 9 and 3. Square root of 9 would be 3, so, and we have a negative, so it would be 3i squared root of 3. So we'd have x equals -3 plus or minus 3i squared root of 3 all over 2. Okay, so those would be 2 of our answers, okay? Plus the one we have right here, what makes x minus 2 go to 0 is 2. Now obviously, we can't have an imaginary answer for the ice sculpture, so our answer is just 2, okay? So if we wanted the dimensions, it would be, the base would be 2 by 2 by 3, okay? 2 by 2 by 3. Think about length, width, and height of the base of the triangle. Which makes sense because at one point we had what? We had it equal to 12, which does work, okay? Think about it. 2 times 2 is 4, times 3 is 12, or 12 divided by 3 is 4, that checks out. Now, in 5.7, what they're going to do is they're going to say find all zeros, not just real, not just, but imaginary and complex. And that's why we're breaking down the problem so that we can get to a point where we can solve for those imaginary zeros. Obviously, we didn't need to on this one, but that's what I'm trying to lead you into, okay? So, you don't have to do that quite yet in this section, but you will have to in 5.7. So finish this, show me before you leave class, and that is it. And bring the questions to class that you have.